Alright, so we need to wrap up this section. The last couple things we did bounded yesterday. So we just need to look at basically in 41 through 46, okay, you're just graphing it and you're finding the max and min, okay, using your calculator. So we'll do one of those. But basically it's the same thing as 25 through 28. It's just you have to graph it yourself on your calculator. So we'll go ahead and start with one of those. Yeah, I do. Alright. So let's look at 42. Yeah. So in y equals, I always do that, x cubed minus 4x plus 1 it's in your book. 95. $42. Everybody have it graphed? Alright, so we're going to hit second trace. You're looking for minimum first. Okay, so we want to find where it's the lowest point, okay, or the low points if it happened to do more than just this one. Okay, so it's going to ask for the left bound, so just get on the left side of the curve, then get on the right side of the curve, and then it asks if you want to guess. Yes. So we would say at x is equal to 1.15, there is a minimum. And did you get all the way on the left side and all the way on the right side? Okay, so you would say minimum at x is equal to 1.15. Okay, then we would want to do the same thing for maximum. So still second trace. You're just looking for the one that says maximum now. You got to get on the left side of the high curve. Then on the right side. Then guess. So we would say there's a maximum at negative 1.15. What? You got 1.96 or negative 1.96? Then my guess is your problem is not typed in correctly. Negative 1.15. Alright, so that's all we're going to do with that. Okay, you just have to use your calculator to tell me where the min and the max is for those ones. So we need to move on to the how to tell if a function is odd, even, or neither. Okay, we're just going to do this algebraically. We're not going to worry about it in any other fashion. So 48, and we'll do a couple of these. G of x is equal to x cubed. So the way I check for even or odd is I plug in negative x for x. If the whole function comes out positive, okay, or doesn't or didn't change, okay, then it's even. If the whole function comes out negative, it's odd, okay, and if it comes out as a jumble of stuff, it's neither. Okay, and we had written this down in our notes. I'm just refreshing. We wrote it down in 8. When we were looking at symmetry, we wrote it down. Like it's got positive and negative signs all mixed in. Like the whole function isn't like negative or the whole function isn't positive. No, it's still going to have like, we'll do one. So we check it. That's supposed to be a g. Of negative x is equal to negative x cubed. Okay. Which then gives me just still negative x cubed. Okay, meaning now this whole function came out to be negative. Okay, essentially is what happens. Okay, you don't need the parentheses, I'm just showing you. That whole function came out negative. Okay, meaning that it's odd. Okay. G of x is equal to 3 over 1 plus x squared. So I still plug in negative x. So I get 3 over 1 plus, and then in parentheses, negative x squared. Okay, which then gives me 3 over 1 plus x squared. Okay, because squaring that negative sign, it becomes positive. So now, because this whole thing basically went back to what it was before I put the negative sign in, it's essentially what you're looking for, it's even. Basically, yeah. 52, f of x is equal to x cubed plus 0.04 x squared plus 3. Well, it can't be both. Okay, so f of negative x, so if I have negative x cubed plus 0.04 negative x squared plus 3, this is going to come out to be negative x cubed plus 0.04 x squared plus 3. Okay, because this term changed and is now negative, okay, it is neither. Okay, because this one is positive, so nothing happened to the whole thing. It just happened to each individual piece. So it's not odd or even. One more of these. H of x is equal to 1 over x. So h of negative x is 1 over negative x, okay, which is negative 1 over x, okay, just so you can see what happened to the whole function, meaning it's what? Odd. Okay? Are we good with even and odd? Okay. It's a good thing your calculator doesn't have to be. Alright, so the next step says to use a method of your choice to find all horizontal and vertical asymptotes of the function. So, the way we write these is x is equal to whatever the number is for vertical asymptotes. For horizontal asymptotes, it's y is equal to, okay? A horizontal asymptote and a vertical asymptote are lines. So we write them as such, okay? So, 56 q of x is equal to x minus 1 over x. Okay, so vertical asymptotes, I'm looking at the denominator. So where the denominator is equal to 0, where does that happen? X is equal to 0. Okay, so that is my vertical asymptote. Okay, and you need to label it like VA and then x is equal to 0. Huh? Alright. Horizontal asymptote. Looking at your poem, what is this one going to have? Or is it going to have one? What does our clown say this one is? So when you're looking at that, you're looking at just this. Both the same. So what does that mean? Coefficient that's in front, in this case it is 1. Okay? As there's nothing in front of the x's. Okay? Whatever number is in front of the x's, top and bottom, that's what you write down. Okay? So in this case it's just 1. Alright, so 58, we're not going to do it, but I'm going to write it down, okay? Well, I mean, we could do this one, but this one's just kind of like a knowledge thing, not anything else. Okay? This one, it wants to know if there's any asymptotes, okay? There are no vertical asymptotes here, okay? It's not a fraction. Horizontal asymptotes, this is an exponential function, okay? Meaning that essentially it's something that is getting bigger, okay? It's like keeps going. Okay, so it doesn't ever cross this line here, okay, because it's not being shifted or anything. So technically the horizontal asymptote is at y is equal to 0, but I'm not giving you one like that, okay? I'm just worried about the ones that are like fractions right now and figuring out what it is. Okay? If you don't understand this one, don't worry about it. I'm just giving you the information in case you were to see it on, like, not likely to come up on an SAT, but I guess it could. Well, then you've heard it before. Okay, P of x 4 is equal to 4 over x squared plus 1. Alright, are there any values that make this denominator 0 to give me a vertical asymptote? Okay, there is no vertical asymptote. Okay, because this is squared, so no matter what I use, I'm still going to have at least a 1 here, even if x was 0. So then how about horizontal asymptote? Bigger on bottom, 0. So horizontal asymptote, y is equal to 0. Okay, yes, because of Bobo. And the last one here, and then you guys will have the rest of the time to work on all the problems. H of x is equal to 2x minus 4 over x squared minus 4. Actually, I probably will do one more just because I want to make sure we've seen the other thing. Alright, vertical asymptote. Okay, so x squared minus 4 is equal to 0. X squared is equal to 4, meaning x is equal to positive or negative 2. Okay, so that means neither of those values work. So that means we have two vertical asymptotes. Okay, so we would write it as x is equal to negative 2 and x is equal to positive 2. Kind of comical because the book only has one answer. I don't know why, but it does. Alright, and then how about horizontal asymptote? Bigger on top. X over x squared? Okay, so that's a good thing for us to talk about though, okay? Bigger on top, we're looking at the powers of x. So I have just an x, and then on the bottom I have x squared. So x squared is bigger than x. Okay, so it's bigger on bottom, which means the horizontal, you're not plugging in numbers. It's purely off the variables, okay? So that means the horizontal asymptote is at y is equal to 0. Okay, if I were to flip this problem, okay, we're going to do 62 modified. If I were to flip this problem, j of x is equal to x squared minus 4 over 2x minus 4. Okay, what would be my vertical asymptote in this case? I modified problem 62 and flipped it. What would be my vertical asymptote if this was the problem? Can x be negative 2? No, so that would be at x is equal to 2. Okay, because you set that equal to 0, solve for x. Now how about my horizontal asymptote? No, okay, no, bigger on top is a no. Okay, there's no horizontal asymptote. Okay, any questions about this? Alright, so your problem's to add on, and then you'll submit everything all as one assignment due Monday. Okay, I gave you guys the bounded ones yesterday for homework, right? Okay. So then today I'm going to add on 41, 43, 49, 51, 53, 55, and 61. Okay, but you do still have literally 25 minutes to work on these, so you should be able to wrap this stuff up probably in this class. Or if anything, only have like 1 or 2 problems for homework depending on how much you've done of the other work along the way. Any questions?